with chapter 5, the last chapter before the exam, before the first exam. And here we have Portland products. They give you the information here about direct material, direct labor, and variable overheads. These are all variable costs. And this is what it was at 130,000 units. And the fixed manufacturing overhead was, as you see there, $849,000. Now they say for the coming year, there are going to be some increases. So direct material is going to increase by 20%. So you take 370,000 times 1.20, you'll get 444,000. What does it say here? Direct labor is going to increase by 4%. So you're going to take 261,000 times 1.04. And then the fixed manufacturing overhead is going to increase by 10%. So that means you're going to take 849,000 times 1.10. And variable cost is going to stay, variable overhead is going to stay the same. So prepare a cost estimate for the volume of 104,000 units. Not 130 like they had before, but 104,000. So what you're going to do is that you're going to, well, first of all, what you would do, you take the new numbers with the percentage increases that I just rattled off, because 370,000 times 1.20 is 444,000. 261,000 times 1.04 is 271,440. And then the variable overhead stays the same, 236,000. So what you would do is that you're going to take, and it says, okay, at 104,000 units. Now, this was done originally at 130,000 units. Variable cost, fixed cost is going to stay the same. Well, you're going to have the increase in it by 10%. But what you have is a change in the number of units. So, remember this formula, folks. I think I've given it to you before. If not, you may remember it if you had me before. If not, write this down. The number of units dropped by 20%, actually. How they get 20% is 100 EV minus BV divided by BV. EV minus BV divided by BV. Write that down somewhere and remember it from now on in life. EV minus BV divided by BV. EV is the ending value minus beginning value divided by the beginning value. So EV, or the ending value, was 104,000. That's the current year. The ending EV is the most current time period. So 104,000 minus 130,000 divided by 130,000, because BV is 130,000, that's the beginning, right? Gives you a negative 0.20. So in other words, the number of units dropped by 20%. So really, production was only at 80% of the original volume. So you take the 444,000, you take the 444,000 times 0.8, 80%, and that gives you, let's do it together here, 444,000 times 0.8, that gives you 355,200 for your direct material. Then you're going to take 271,440 times 0.8, 80%. That's 217,152. And then 236,000 times 0.80, or 80%, equals 188,800. Add all those together for 355,200, the 217,152, the 188,800, plus the fixed cost of 933,900, because don't forget it went up by 10%. Add all of that together, and well, what you're going to get, I guess for this year, as it says here, those are the numbers there. You see that right here? Yeah, but I just told you how to get these. Don't forget, they don't show it to you here. Well, at least I don't think they do. Well, they do. Oh well. Yeah, you can look at this. But the way I said it, multiply that by 1.2. Well, 120% is 1.20. 104% is 1.04. Don't forget, 1 is 100%, right? So these are the increases, but production dropped by 20%. Now what they did, they took the 104 divided by 130. And you can do it that way. I mean, you can do it that way. The way I did it, I said, well, it's a 20% drop, which means then you're at the level of 80%. And if you take 104 divided by 130, that is 80%. So just a different way to come to the same thing. Now we know that this was the previous year's cost. They gave this to you up there. And this is the most current year. Now, you look at the unit cost. What's the unit cost for each year? Divided by the number of units. So for the previous year, the 130,000 units, the unit cost, manufacturing cost is $13.20, and the current year is $16.30 per unit because production dropped, and therefore more fixed cost was added to each unit. So they go $13.20 and $16.30. Okay. Next, the second one. As you recall, with the learning curve, each time the output doubles, that's a percentage of the number of hours it took is a percentage of the previous number of hours. So what we have here is a 50% learning curve. That means each time output doubles, it takes 50% less time than before. You see at level, the first time, 9 hours, 9.000 hours. Now it doubled to the second time. Financial statements you proofread at 2, which is double of 1. 50% of 9 is 4.5 hours. Now, that's when you proofread 2 financial statements. Now you're going to proofread 4, double the 2. So there's going to be 50% of 4.5, okay, which is 2.2500. 2.2500. Then at the 8th financial statement, the 8th financial statement that you proofread is 50% of the previous amount of time. So 50% of 2.2500 is 1.1250. 1.1250. Then by the time you get to the 16th, again, doubling the 8, by the time you've done 16, is 50% of 1.125, which is 0.5625 hours. A little more than a half an hour. Okay? And that's what you have here. All right, 2.25, 1.12, and 0.5625 hours. Now, if they're being paid $15 an hour, what is the percentage of the cost of proofreading the 16th to, it's like a ratio. The first one to the last one, the 16th one. The 16th one to, that is opposite. The 16th one to the first one. Okay? So if you take 15 times the first financial statement proofreading is $135. Took you 9 hours. By the time you did the 16th one, it's 0.5625 hours times 15 is $8.44. So that's the 16th one, right? So 8.442, 1.25, or that is 8.44 divided by 1.35. That is the 16th to the last one, the percentage. Well, 8.44 divided by 1.3 divided by 135 is 0.06252, which is 6.25%. Okay. Alrighty. And that's what you should see here. Yeah, 6.25%. Okay. All right, let's go to number 4. No, is it? Oh, 3. I'm sorry, number 3. Now, I want to show you how to read this. It's a simple regression. And the simple regression is y equals a plus bx. That's the simple regression. There's also a formula for a straight line. And we use that formula for other things too. So, y equals a plus bx. The a is a in statistics you call the constant or the fixed cost. Basically, it's constant, so it's a fixed cost. So what you do is insert labor hours where it says labor hours. And what does it say? What are the labor hours here? 3,000 labor hours. So it will be 43,422 plus, in parentheses, 87.8 times 3,000 hours. And you do the math and you should come up with 306,822. Okay? But I want you to be able to read this. And by the way, look at the correlation coefficient. That means that there's a moderate relationship. Not a strong one, not a weak one, but a moderate relationship between labor hours and overhead cost. Now, look at R squared. If you take 0.606 and square it, you get 0.367. That means almost 37% of the reason why overhead cost changes is attributable to the changes in labor hours. Let me say that again. 0.367 is 36.7%, or almost 37% of the variation or the changes in overhead are attributable to changes in labor hours. The other 63%, some other factors are involved, which are not noted here. Okay? I want you to be able to understand what that means. Alrighty. So that's, and another thing before we leave this page. Overhead is the dependent value. Labor hours is the independent value. Y, again, y equals a plus bx. So y is the overhead. A is the 43,422. That's the fixed cost or the constant. And B is the $87.80, and X is the labor hours. So don't forget to know what the independent and the dependent variables are. Okay, let's go to number 4. And this is straightforward. If you read this, I'm not going to spend time on this because it is so straightforward. And all you're going to do is multiply these hours this cost by the number of hours. They say 30 hours times 700 gives you $21,000. $185. Excuse me, 185 hours times $350. See that there? It's just multiplying and adding them all up. That's so simple. I probably won't even include it on the exam. I mean, that's just. Well, let's move on to number 5. Now, number 5 is another learning curve one, but they have a formula here: y equals ax raised to the power of b, and b is a negative 0.358454. That would be fine, but not everybody has a calculator that can do that. You have to have a, like I have a TI-84. I can do it, but I'm not going to assume that you have that kind of calculator. But what you should note is that look at the doubling here. It says a 78% learning curve. 100 hours the first time. The second time, which is doubled now, 2 is the double of 1, is 78% of 100 is 78. Look at 4. Skip 3, but look at 4. 78% of 78 is 60.48, 0.84. Then go down to 8. 78% of 60.84 is 47.46. That's what I want you to know. I'm not going to take you through this here because, again, that's to assume everybody has the calculator. And, you know, my experience has been half the students bring the simple calculator, which is okay for the most part. These other calculators are expensive. And, well, anyway, just know that you can see it every time the output or the number of units produced doubles. That's when the learning curve percentage applies. If you want to calculate the time required between the doubling, like a 3 or 5 or 6, well, you're going to need, again, a formula like this up here, which we're not going to be using. Okay? And there you go. See, you got to, well, you see that, what it does there. Okay? You won't, on an exam, there will be learning curve problem, but it'll be straightforward, like the one we had before. Okay, 6 through 10. Now, let's go, here I'm going to do this. I give you this information here, but they expect you to use, and some of them, simple and multiple regression using a spreadsheet. Again, not every student has access to Excel, and not every student knows how to use Excel well enough to do it. I'm not going to impose that on you on the exam, having to use a spreadsheet, but you will have to know, and I know how to interpret simple and multiple regression, especially multiple regression. You need to know how to explain it. So let me see which one here. Number 6 is straightforward. 450 cases will be shipped, and we got to determine the variable cost and estimated operating cost. Well, you get this up here, right? They tell you how much of this 207,000 is fixed, and then of course the rest will be variable. And if you bring it down here, they took that information, they broke it down according to what it said, fixed and variable, and then you just, again, straightforward, you do the math here. Okay, we see the fixed is that's your A, and the BX is, again, the variable cost per case is 840, and the number of cases, in this case, 450,000. So Y equals, again, A plus BX. A is the fixed cost. B is the variable unit cost. In this case, was figured out to be $8.40, which they show you here, right? You got the variable cost there, 3,780,000, divided by the number of cases. So it's very straightforward, folks. Okay. Number 7. Number 7, use the high-low method. Now, let me work that out for you here. I'll show you anyway. Well, let's go back up here. First of all, we look at the level of activity. Not the cost, but the level of activity. Okay? So here, now they have them in order for you. It won't always be that way. That is the highest and the lowest. High-low method. The highest number is 456,000 cases, and the lowest is 258,000 cases. The associated cost are 6.3 million there, and at the top 5.6 million. So what you do is you take this highest cost, 6,362,269, minus 5,699,153, divided by 456,000 minus 258,000. And when you finish the math, you're going to come up with 3.34907. I took it out to 5 decimal places. 2 would be fine. Well, round it off. So it would be 3.35. But I took it to 3.34907 per case. Now we have that. We're going to take the highest cost, or we could have taken the lowest, but I'll take the highest, 6,362,269 minus, in parentheses, 456,000. Okay, that's the associated number of cases, times 3.34907 or 3.35. And that'll give you 4,835,093. Now, why do you subtract? Because the 4,835,093 is your fixed cost. See, here you have total cost, 6,362,269. We take the total cost and we're going to subtract out the variable cost, which leaves you with the fixed cost. That's why I subtract. Once you get the fixed cost, then you go with y equals a plus bx, right? So a would be 4,835,093 plus the variable portion, 3.34907 or 3.35x. And then we're going to say x is 450 cases, which will give us then a total cost of 6,342,175. Mine's a little higher because I took it to 5 decimal, how many decimal places? 5 decimal places. But if you took it to just 2 decimal places, 3.35, you'll get this. So mine was 6,342,175. I was more accurate. But again, let's say round the variable cost and then round the intermediate values to the final to the nearest whole dollar. Well, I did it all the way through the all 5 decimal places. Okay, so that's how you do that, the high-low method. And again, this is how they did it. Oh, they took it to 5 decimal places like I did. Okay. We got the same numbers. I have the same numbers they do. Well, they have the same numbers I do. That's the way I look at it. 4,835,093 plus 3.34907, which is what I got, times the 450. Why did they get the 143? I got 175. That's peculiar. Wow. Let me just double check my math. I mean, we got the same numbers. I came up with the same numbers, 4,835,093 plus, parenthesis, 3.34907 times 450,000. Yeah, I get 6 million. My calculator says 6,342,174.5. And I took it to 175. That's really strange. I mean, the exact same numbers. Well, folks, I'm not going to belabor that point. That's why I liked in class. I used to have my test, a paper test, and anyway, I'll get to that later. That is so peculiar. I would say that they're wrong. I'm right. On your calculator, folks, when you do this, see what numbers you come up with. Of course, you know what? Yeah, you do this on your calculator. This now, if you close out and then come back to this, McGraw Hill will have changed. Same problem, but the numbers will be different. So anyway, that's neither here nor there, I suppose. 8. Okay, here's what I want you to know. Again, it says using Excel. We're not going to use Excel for the reasons I explained. And estimate 450,000 will be shipped. Now, don't forget, if you remember from junior high, what they call it middle school now, I'll tell you how old I am, right? The intercept, you remember on the slope of the line, it's called the y-intercept. The intercept is the constant, or it is the fixed cost. So what this means is that y equals 5,183,317 plus, open parenthesis, 2.22819 times the number of cases, 450,000. Okay? And that's what you see here at the bottom. As I said at the bottom, yeah, that's what it is. Okay? Now look at this again. The intercept is A. It is the fixed cost. And then they have the number of cases, which is the variable portion. Now, look here at R squared. R squared. 58% of the changes in cost is due to the changes in the number of cases. It is a strong relationship, though, 0.76. That's a healthy correlation, okay? All right. So even though I may not have you run a multiple regression or a regression, you need to be able to interpret it. Okay. Number 9, same thing. Okay, same thing. It's the same thing. Of course, this is multiple regression. They added price index. They added one more independent variable. So what you're going to do is you take that constant, the intercept, y equals 4,606,742 plus, open parenthesis, 0.94688 times the number of cases, close parenthesis, plus, open parenthesis, 8,380.08648 times the price index. And you'll get a number. And as you can see, the addition of the extra independent variable raised the R coefficient by a few decimal points, and R squared also. Okay, so R squared with the additional independent variable, R squared is 0.699. Without it, it is 0.58. So adding an additional independent variable increased the accuracy. But, and that's number 10, that extra variable can be argued not to be relevant. And so they say the simple regression is perhaps more relevant, more accurate. That's something, a philosophical, not philosophical, but even a technical question, I think, beyond the scope of this class. Can be argued. It can be argued another way. Okay, we're almost finished, folks. We got 2 more. Number 11, high-low method. And again, we're going to take the cost, $6,875 minus 3,683 divided by 3,550 minus 1,870, and you do the math, you come up $1.90 per visitor. Okay, that's the variable portion. So we take the cost, total cost of 6,875. We're going to subtract out the variable portion. So 6,875 minus, in parentheses, 3,550 times 1.90. That gives you 130,000, because these are in thousands. Remember, it says here, thousands. And so we take 130,000 plus, that's y equals a plus bx now, and a on the fixed cost is 130,000. We just figured that out. Plus, open parenthesis, $190 times 2.8 million, and that's going to give us 5,450,000, and that's what we have. Yeah, that's what we have here. We agree. Okay, and our last problem. Again, this is using again the high-low method. Oh no, okay, no, they're running a multiple regression or simple regression, and because there's only one independent variable. Again, as you can see here, the revenues will be the independent variable, and we're trying to predict the dependent variable, maintenance and repair costs. And so again, what's the formula? Y equals 3.8257 plus a negative 0.0337 times the amount of revenue. So let's do an example here so you can see how it works. Take your calculator. Again, revenue on the right is the independent variable. Therefore, we're going to multiply it by this 0.0337. It's a negative number. Let's take a look here. Let's do a couple of examples, then I'll let you go. Let's take 107 as revenue. Okay, so we're going to say, take a calculator, we're going to have our intercept, which is the y equals, write this down, y equals, then the intercept is, so that's A, so it'll be 3.8257 plus, in parentheses, a negative 0.0337 times 107. And that will give us 0.219, so 22 cents. And here they got 26 cents, so it's close. It will never be completely accurate. Remember when we talked about that in the PowerPoint slides, the standard error? Okay, let's do another one. Let's do 63. Let's take July, 63. So let's again take y-intercept, so the constant is 3.8257 times, open parenthesis, a negative 0.0337 times, what, 63, close parenthesis, and that gives us, what did I have here? Oh, I multiplied, I put in the wrong number here. Let me do it again. 3.8257 plus, open parenthesis, a negative 0, boy, big fingers here, 0.0337 times 63, close parenthesis, and get $1.70, which is 2.10. So that's off a little bit, but you get the point. This is how, we don't know how well this fit here is 78%, so 79%. So it's a good fit, R squared is 0.79. So that's a decent fit. But again, it won't be 100% accurate. Let's just do one more for the L of it. 3.8257 plus, open parenthesis, a negative 0.0337 times 49, the first one, get 217. So that's the gist of it, folks. It won't always be accurate, but apparently it's close enough. If you got, wow, R squared 0.79 pretty much. Okay, that's it for today. Do well, take care of yourself, be safe, and hope this helps a lot. Okay, so let me just get out of here.